Hello, today we are talking about angles in polygons. This is actually an extremely important topic. We're going to use this for the remainder of the year. You'll see quite a few of these style questions on your SOL. So what we're going to do is we're going to look at the figures we have on the front, and step one is to identify the name of each polygon along with the number of sides. So in what we have, this first figure is a triangle, and we know that. And we know that it has 3 sides. This next one, I know it looks like a rectangle, but I'm going to call it a 4-sided figure, a quadrilateral. And we know that it has 4 sides. I'm going to move down to the right, and this shape has 5 sides, and the name of this polygon is a pentagon. And again, circling around, the next shape has 6 sides, and this shape is a hexagon. And then finally moving back up, hold on, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 sides, and the name of this polygon is an octagon. And you do need to know, octagon, you do need to know what these names are. So the directions actually say, let me scroll back up again, that we need to fill in the chart on the back. So if you turn your paper over to the back now, we're going to enter these shapes into our chart, and we're going to put them in order by number of sides. So what I mean by that, in the chart, the first polygon that I'm going to write in is a triangle. And its number of sides is 3. The next one will be the quadrilateral. And its number of sides is 4, etc. So what I'm going to do is I'm going to put my other page back on, and I want you to complete the chart, again, going in order of the number of sides. So go ahead and pause your video now and fill in your chart. Okay, so we should all have our chart filled in, and it should look like this. So if you do not have this, please pause the video now so that you can fill in your chart. I'm going back to the front. So back on the front, we've done step 1. Check that one off. We need to now do step 2, which is to divide each polygon into triangles. The directions on how to do that are written right here. Pick one vertex and draw lines out to every other vertex. Do not do this for all the vertices, only one. Now in the triangle, I cannot divide this up, because if I draw from one vertex, I've chosen this one, out to another, and out to another, I have the same shape. So I only have one triangle. So the triangle has one triangle in it. So let's move to the quadrilateral. Again, you may choose any vertex that you want. And all I'm going to do is I'm going to draw out to all the other vertices. So when I draw out to this one, I don't create a triangle. When I draw along the bottom, I don't create a triangle. But when I draw diagonally through to the other side, I now have 2 triangles. And again, I'm only going to do it from one vertex. I pick one vertex and I draw out to the other ones, and I have 2 triangles. So from here, let's do the pentagon together, and then I'll let you do the other 2 by yourself. So for the pentagon, again, you may choose any vertex you want. I have chosen this one. So I draw out to all the other vertices. This one does nothing for me, and again, along the bottom, that one does nothing for me. Then I draw out to the other vertex up the tippy top, and then I draw out to the vertex that's sort of at the top right. And how many triangles have I created? 1, 2, 3. So this one has 3 triangles. So what I would like for you to do right now is I want you to do the same thing for the hexagon, and I would like you to do the same thing for the octagon. So please pause the video now and do your hexagon and your octagon. So for the hexagon, I got 4 triangles, and for the octagon, I got 6 triangles. So now what I'm going to do is I'm going to go back to my chart on the other page, so turn your paper over, and we're going to fill in the number of triangles that we got. So for the triangle, we got 1 triangle. I'm going to flip back so we can see our work. For the quadrilateral, we got 2 triangles. For the pentagon, we got 3 triangles. For the hexagon, we got 4 triangles. And finally, for the octagon, we got 6 triangles. Now, the whole point was we actually want to know, well, what's the sum of all the angles in the polygon? What I mean is, if I add up all the angles inside of a triangle, for example, so if I have a triangle and I add up all the angles inside of a triangle, we know that adds up to 180 degrees. We've already known that. So I'm going to go back to where my figures are. So go back to your figures. We'll fill in the table in just a minute. And in this one, in the rectangle, I'm over here, I have 2 triangles. So this red angle, and this red angle, those all add up to 180 degrees. Okay, well, this blue angle, and this blue angle, and this blue angle also adds up to 180 degrees. So because there's 2 triangles, that means we have 2 180s. That's going to add up to all the angles in the triangle. So that, I mean, the quadrilateral, I would have this angle plus this angle plus this angle plus this angle better be 2 times 180, which is 360 degrees. So back to our table, we know the angles inside a quadrilateral will add up to 360 degrees. We've actually talked about that one before. So let's move on to our pentagon. For our pentagon, again, I have 3 triangles. Well, the first triangle is going to be 180, the second triangle is going to be 180, and the third triangle is going to be 180, and that will give me all of these angles added up have to be 3 180s. And 3 180s is 540 degrees. So we can put that in our table. 540. Anytime I have any kind of pentagon, all the angles inside the pentagon will add up to 540. Back to the front again. I would like for you to do the same thing for the pentagon, the hexagon, and the, I want you to do the same thing for the hexagon and the octagon. Please calculate the sum of the interior angles for those 2 shapes. So for my hexagon, I have 4 180s, which gives me 720 degrees. And for my octagon, I have 6 180s, which gives me 1080. So go ahead and go to the other page where your chart is and fill in your chart with your 720 for the hexagon and 1080 for the octagon. Okay. Now the point of this is not to memorize the sum of the angles for each shape. I do not want you to do that. But what you do need to know is, how do I start with the number of sides of a polygon and figure out what the sum of the angles is? Well, what I was doing was I was taking the number of triangles and I was multiplying that by 180. So it's number of triangles, and I really was multiplying that by 180. So 1 times 180 gives me 180. 2 times 180 gives me 360. 3 times 180 gives me 540. 4 times 180 gives me 720. And 6 times 180 gives me 1080. So the question now is, well, how do I get from the number of sides to the number of triangles? Well, what was I doing every single time? Well, what do I do from 3 to get to 1? What do I do with 4 to get to 2? What do I do with 5 to get to 3? 6 to 4, and 8 to 6. Every single time I'm subtracting 2. So that is what I'm going to do every time, no matter what the shape is. If I know the number of sides, I'm going to take the number of sides, subtract 2, take that number and multiply by 180. So let's write that formula down right here. So we are going to do, we first started out with the number of triangles and we multiplied that by 180. But if we want to start with the number of sides, I need to take the number of sides, I need to subtract 2 and multiply that by 180, because the number of sides subtract 2 gives me the number of triangles. The next question, we've talked about regular polygons before. That means that all the sides are congruent, But more importantly for what we're working on, all the angles are congruent. So the next question. Find the measure of one interior angle of a regular hexagon. So I'm going to start this from the very beginning as if I didn't have this chart in front of me. So for a regular hexagon, that means it has 6 sides. So if it wanted me to answer the question, what's the sum of the interior angles? That would be the number of sides minus 2 times 180, which is 4 times 180, and if I pick up my calculator, that should give me 720. So that's the sum of all of the interior angles of a hexagon, which has 6 sides. But that's not what I was asked for. I was asked for one interior angle. Well, if a hexagon has 6 sides, it also has 6 angles. Whatever the number of the sides is, that's the same as the number of angles. So one interior angle, I don't need an S on angle, one interior angle will be that 720, the sum, divided by the number of sides. Now, my sum was 720, and I take that and divide it by the number of sides. And when I do that, I get 120 degrees. That is one interior angle of a regular hexagon. So the next question is, well, what's the formula now for finding the measure of one interior angle of any regular polygon? Well, all I did was I took the sum of the interior angles and I divided it by the number of sides. But let's write this a little bit better because I know the formula for the sum of the interior angles. And the sum of the interior angles was the number of sides, subtract 2, multiply that by 180, and divide that by the number of sides. Now, what most people do is they call the number of sides n. So typically, you will see this formula look like this. Now, whichever way you want to remember it, you must memorize this. Okay? We have to memorize this. We have to memorize this. That will never be provided. Okay? That you must know those formulas. If you need to write that down, pause the video here as I'm moving forward. The next thing we're talking about are exterior angles. So let's just look at this figure. The exterior angles are angle 2, angle 3, and angle 1 are each exterior angles. Now the question is, what's the sum of the exterior angles? If I were to add up angle 1 plus angle 2 and angle 3, what would I get? Well, not quite sure yet, but I know that if I did from here to here, that would be 180 degrees. I know that. So I have 180 degrees. I know from here to here is also 180 degrees, so that's another 180. And finally, I know this one is also 180 degrees, so I get 3 180 degrees, which I think is 540. But I don't want all of that, I just want the exterior part. So I want to subtract out this much, that's inside my triangle. I need to subtract out this much, that's inside my triangle. And I need to subtract out this much, which is inside the triangle. Which means how many degrees are inside the triangle that I need to subtract? I need to subtract 180. So I subtract 180, which means these cancel out, and I'm left with these 180 and 180, which is 360. So the sum of the exterior angles of a triangle is 360. Now, if we do this with a quadrilateral and a pentagon, guess what? We're going to get 360 again, and we're going to get 360 again, which means the sum of the measures of the exterior angles of any regular polygon is 360. You must memorize this. So that's a very nice one. So let's say I said find one interior, sorry, not interior, one exterior angle of a regular hexagon. Well, I know the sum is 360, and I would need to divide by the number of sides, or the number of angles in the hexagon, which would be divide by 6, which gives me 60 degrees. So exterior angles are awesome. They are your friends. The other thing that we need to note is if I have an exterior angle and an interior angle, so if I have this situation here, angle 3 and the interior angle are going to add to 180. And that will happen here, and that will happen here as well. So if you go to the next page, I'm going to scroll down to number 5. The relationship between one interior angle and its exterior angle is they add to 180. Now, what I'd like you to do right now is pause the video, and I want you to complete 1 through 4, please. So pause the video now. Here are the answers to 1 through 4, and you may write it in either way. You do not need to write 1 and 3 in 2 different methods. Whichever method you want to go with, using n or using the number of sides is what you need to do. If you need to write these down, pause the video now. If you've got it all written down, bring your questions to class and have a wonderful evening.